Hello. Hello, hello. Good evening. Is my voice clear? If it is clear, please let me know in the chat box. Hi. Yes, lesson 2 is conducted by teacher Miu. Yeah, when you hear this one, that means we are started. All right, so here we go. Before the lesson 2, let me just again introduce our GEP math. The GEP Math Advanced Modular Bootcamp. All right. So for the GEP Modular Bootcamp here, for the advanced module, actually altogether we have again 5 different module. And for these 5 different module, is like for the first one, which conducted by teacher Apple on Tuesday already, is on words problem. And then for today, it will conducted by teacher Mew on the words problem 4, which will basically focus on working backwards, which we also have learned this for this week long-term class. And also we will talk about the periodic problem. And for next Tuesday is on calculation. And next Friday is on combinatory, and also the next Tuesday is on numbers theory. And in the end, for the next Friday is on a revision on all these topics. Then we will just finish most of the topic we must know for GP. All right. So after that, let's just come to the first one, working backwards. For working backwards is actually quite a very funny one. Now let's just come to a guessing time. It says 3 is added to a number. All right. And then the sum is then multiplied by 6. When 10 is subtracted from the product, then the result is 20. So what is the number? So now I will just give you 30 seconds to find out the answer. Let's just try. Let's try. Just have a go. Right. So far I don't get any correct answer. For this question, this is very, very easy one. So basically for such a question, we shall finish it within 30 seconds, right? So actually, this is a very typical question related to working backwards. It's like we know what's going on and also we know the result. Now we need to go all the back to the very, very beginning. So that's why we need working backwards. So for working backwards, one very important tool is called the train diagram. It's like now we have a number we don't know. 3 is added to the number. That means we should plus 3 to the number and get to a new number. For this new number, then multiplied by 6. That means times 6. Then it goes 10 is subtracted from the product. That means we still need to minus 10 to get to the result, which is 20. This is what the question told us. But don't forget that we need to go all the way backwards to find out, which means when you minus 10, you go backward, you should plus 10. Good. So when we do plus 10, then you will find out it is 30. Then when it is multiplying 6, then you will get 30. You go backwards. What should you do then? Actually, you shall divide it by 6 to find out. At first, it's supposed to be 5. Then again, you go backwards. When you go plus 3, you get to 5. So you go backwards, you should minus 3 to get it, which is 2. So originally, this number is 2. Then follow this order all the way to the end, you got 20. This is what we call as the train diagram of working backwards. But in GEP, would that be that easy? Actually, it would be. Actually, it would be that easy in the first round. But what about in the second round? Let's just take a look at this question. Now is the fruit time. Teacher Apple ate half of the bananas. So how many bananas are left? Can you just super fast and let me know? Altogether, we have 20 bananas and teacher Apple ate half of those. Actually, it should be... All right, good. Actually, it should be very easy, all right? So altogether, we have 20 bananas. And since we have 20 bananas here, half, that means divided by 2. When we divide it by 2, you will find out we still got 10 left. This is something you need to notice. I have a question. Do we need to use Altogether 20 minus 10 here to see, oh, we still got 10 left. Do we need that? No. This is something you need to pay attention to. Actually, we don't need this step. This is only a step that wastes your time. Because when teacher Apple eat this half, she would definitely have the other half left, which would be totally the same as the half she ate. Right? So like say she ate this half, then she will have the other half left, right? Which is totally the same. So when you divide it by 2, you can just direct have what's remain. This is what we have as take half, leave the other half. So in train diagram, first thing first you need to notice is First thing first you need to notice is the bracket shows you the leftover, what's remain, right? And the second thing is what you need to remember. You take half, you will leave the other half. When you take half, you leave the other half, then you don't need to do the minus anymore. This is one key you need to remember. Continue. What about now? Let's go further with this crazy question. It goes, Jason bought some sweets and he gave half of the sweet to his mother. Then he gave a sweet to his sister. After that, Jason gave half of the remaining to his brother. In the end, he was left with 30 sweets. How many sweets did Jason buy? For this question, this is very obvious, a working backwards problem. Because we know what's going on, we know what's in the end, we need to go all the back to the start. That how many candy did he buy? Right? So it's about working backwards. When it is working backwards, we should draw the train diagram. Right? So let's just draw the train diagram with me, right? First thing first, we have a bag for Jason carrying all the sweets inside, right? And then he gave half of the sweet to his mother. That means what? Do you remember? Half means what? Half means good. That means divided by 2. Do I still need to take away those after divided by 2? No need. Why no need? Because when you take half, you leave the other half, which is totally the same. So you direct divided by 2, you will get the remaining as the other half. Don't forget, take half, leave the other half. Continue. Then he gave a sweet to his sister. That means we need to take out a sweet from the bag and give it to sister. So minus 8. Then continue. Jason gave half of the remaining to his brother. What does it mean then? That means we should, again, half means what? Half means divided by 2. So then again, we divided by 2. And in the end, he still got 13 left. So now we need to go all the way backwards to find out what does he have at first. So what should we do? Let's try there. Let's try. Which is here is supposed to be times 2 to go to 26. Here minus 8 is supposed to be plus 8. Then we get 34. Since it is divided by 2, we go backwards. It's times 2. So in the end, we will have 68. Right. So this is about, well done dear, good job. This is what we have from working backwards. Always remember, when you give half, you will have the other half left. So direct divided by 2 is enough. You give half, you get the other half left. Right? And continue. Now the question just become a little bit crazier. It's like this one. What if now Miu eat one more than half of her pears? Then how many pears left? For those who are my students, I mentioned this before. I mentioned this week. When Miu eat one more than half, that means Miu should eat the one more first, or I should eat the half first. Good. Actually, I should take out the half first. This is the half. But that's not the end. I still eat one more. Altogether, this part shows you one more than half. So this is actually what we have as one more than half that Mu has eaten. So in the end, we still got 2 pairs left. In train diagram, how can we show that? That is at the very, very beginning, I got 6 pairs in the fridge, right? And just like what I eat, first thing first, I take out half first, right? That means half means what? Good. Right then there. Half means divided by 2. All right. So I take out the half, I eat them, and I still got 3 left in the kitchen. Then I still need to eat one more. This is one very important key. What does it mean, eat one more? For eat that one more, should I do plus here or minus here? Oh, very tricky. I will ask again. For this one more I eat, should it be plus 1 or minus 1? I repeat, the bracket refers to the remaining pairs in the kitchen. I still got 3 remain, and I eat one more, then how many remain? It's supposed to be plus or minus then? Minus. Because you cannot put milk inside the fridge, right? You need to take out from the fridge and eat it. That's why it's supposed to be minus, then you will still got 2 remain. Moral of the story, for like say one more than half, we always do the half first, which is divided by 2. Then you need to take out that one more, which I need to eat. You cannot put milk inside the fridge. No way, I'm not getting into the fridge. So you need to take it out from the fridge and eat. That's why it's supposed to be a minus. Continue. What about one fewer than half? That is another story. So milk is 1 fewer than half of her pairs. So how many pairs left? First thing first, I should eat the 1 fewer or I should eat the half? Well done. Always eat the half first, right? Good. So I take out the half of the pairs. As in the fridge, I got 6 pairs now, right? I take out half. I still got 3 remain in the fridge. Okay. But did I finish all these 3 as a half? No. Since I eat 1 fewer, that means I still got 1 pair as 1 fewer pair than half. I didn't eat. This 2 shows 1 fewer than half. So basically, I only eat this 2. Okay. That means I still got 1 fewer I didn't eat. What should I do to that 1 fewer pair? Should I throw it away? Can I? Oh, for that 1 fewer pair I didn't eat, I need to throw it away. No way. So for that 1 fewer pair I didn't eat, I should put it back into the fridge. That's why here it's supposed to be a minus or a plus. It's supposed to be a plus. So here, that's why you will get in the end, I still got 4 pairs left. This is about 1 fewer than half. I repeat, 1 fewer than half. We do the half first and put the fewer back. Because the 1 fewer I didn't eat. So I need to put it back into the fridge or put it back into the kitchen. No matter where it is, we should put it back. Let's just try one very crazy question. All right. It's about flying birds. That is another type of the question. We have 24 birds resting on 2 trees. 3 birds flying from the first tree to the second tree, and then 5 birds is flying from the second tree to the first tree. Now the 2 trees have the same number of birds. So how many birds are there on each tree at first? Guys, I got a question. If this is the first tree, wait, this is the second tree. 3 birds from it coming from the first to the second, and then 5 flying from the second to the first. Would the total change? No way, right? No, because we can see here as the 2 trees as a whole. No matter you are flying to the first tree or the second tree or the first tree, the total would always be 24. So this is something you need to remember. This is what we call as the internal exchange. The total wouldn't change. So when we are doing this one, we need to draw two train diagrams. One is for the first tree and the other is for the second tree. At the very first, you got some birds on the tree and then three flying from the first to the second. So to the first tree, what happened? Three is flying away, bye-bye. Right? But at the same time, what happened to the second tree? Three birds are flying in, right? Which means we should plus three birds. Okay, then continue. This is the first transfer. What about for the second transfer? It's like five birds are flying from the second tree to the first tree. So what happened to the first tree? Well done. Five of those are flying from the second to the first. That means we will got five more on the first tree. Then what about for the second tree? Five bird is flying away, right? That's why it's supposed to be minus five. And it goes in the end, both tree got the same numbers of birds. Do you know exactly how many birds there? Do you know exactly how many birds in the end of each of the tree? Well done. Because altogether there are 24. And the total won't change. And since they got the same number, that means each tree should have 12. Now we can go backwards. When we go backwards, for here, you're supposed to take away 5 to get 7. And for here, you should plus 3 to get to 10. What about for the second tree? Do you need to finish this train diagram to find out how many birds are there on the second tree at first? No. Actually, you don't need to do the second train. You know why not? Because altogether there are 24 birds. Yes, well done. Because as the sum, there are 24 birds altogether. If so, 10 of those are on the first tree. What about the remaining 14? Must be on the second tree. So this is also one very important tip, that is the sum won't change for the internal exchange. Right? You can just find out one of it by knowing the other one. Here we go. Let's just go further. What about now? Now altogether, we have 120 apples in A, B, C. And they took some apples from A to B, such that the numbers of apples in B double. Hey, I got a question. What does it mean double? What does it mean double? Good job. Double means times 2. Right? Continue. Next, he took some apples from B to C such that the numbers in C double. Which means double, right? Good. Continue. A, B, C have an equal numbers of apples in the end. So how many apples were there in the bag at first? Let me just show you. Again, asking at first, all right, for GP, one very important secret. One very important tips. GP is always about time, about how you manage your time and do it in a very fast way. So guys, when you see at first refers to working backwards. When we are doing working backwards, we should draw the train diagram. This should be kept in mind. All right, that is every time you see at first, working backwards. Working backwards, what you do? Train diagram. Very important. If so, train diagram for A, B, and C. Right? Altogether got 120. It doesn't matter. Later we will use it. It says Andy took some apples from A to B such that B got double, right? So we draw. For the first very important transfer from A to B, B got double. So for B got double. What about for A? What happened to it? This is very important question. I need you to think about this. When B got double, What happened to A? Does it mean divided by 2? No way. I give you a very important example. What if at the very, very beginning, B only got one apple? You got double, then actually you only have 2, right? What if at the very, very beginning that A has here got 100? He's giving B actually how many apples to make it double? He's only given it 1, right? So for A, does it mean divided by 2? No, right? He's only taking out 1. How comes it is divided by 2? That's why multiplication is only for one person. You cannot at the same time do division to the others. So this one, keep in mind. What you know is A is taking out something. What you can confirm is A is taking out something, but you don't know how many. It doesn't matter. Yeah, it won't matter. After you finish the whole train diagram, you will find out this one, it won't matter. So continue. If so, right, for B, she got double, and for A, he taking out something. It doesn't matter. But for C, anything happen to C? Nothing happened, right? Okay, so we keep it. For the second one, second transfer from B to C, that makes C double. So for C, what happened? Good. For C, times 2. But at the same time for B, does it mean divided by 2? No. This is what I just mentioned. Multiplication only works for one people. When you got double, it doesn't mean that I need to give half. We are two different people. I don't need to do that. Right? If you only want to get double, I only need to give you 1. Why I need to give you half? So for B, he's only taken away something. But we don't know. Once again, it doesn't matter. Right? So keep it. Continue. For A, nothing happened, right? So keep it. In the end, they got equal numbers of apple. Hey guys, do you know that in the end, how many apples they have? Each of those. Ayo. It's okay. My question. Okay, focus here. In the end, do you know in each of the bag how many apples? Altogether, you have 120 as a sum and they got equal numbers. Well done. That must be 40 each. Perfect. Now let's just go backwards. A, B, C, which is the easiest to go backwards? Definitely A, because A happened, nothing happened to A. So we go backwards, 40. Then B and C, who is the next to go backwards? Definitely C, divided by 2 to go to 20. Do you know B then? Do you know B then? Do you need to know what's the star exactly? No need, because the total is 120. 20 is at C, 40 is at A. So how many at B? 60 total 120. Same steps for the first transfer. What should we do? Good. It's supposed to be 20 for C. What about for B? Divided by 2 to find out it is 30. Okay, then what about A? Do you need to know exactly what the triangle is? No need, right? All right, focus. Focus on the lesson, all right? Altogether, it's supposed to be 120. So for A must be 70. This is one very important thing about internal exchange. Some never change. But then they are excellent. All right. So after that one, we are just coming to the periodic problem. Periodic problem is actually about division. It's about remainders and division. All right. So guys, are you ready? Here we go. The flowers are arranged in the following continuous pattern like this. We have 1 pot of red flowers, 2 pots of yellow flowers, and 2 pots of pink flowers like this. 1 red, 2 yellow, pink, pink. Or you like say red, yellow, yellow, pink, pink, red, yellow, yellow, pink, pink, and continue. It's supposed to be, yeah. We can just continue with red, yellow, yellow, pink, pink, and continue. Just go red, yellow, yellow, pink, pink, right? So easy. Okay, now the question is on, what about the 50th pot of flowers? What color is it? Any idea? Hey, focus on the question. This question is funny. What color is the 50th pot of flowers? Are you going to continue with red, yellow, yellow, pink, pink, and red, yellow, yellow, pink, pink, and then red, yellow, yellow, pink, pink, like that? Of course not, right? Actually, you will notice that those flowers are arranged by groups. Red, yellow, yellow, pink, pink, one group. Red, yellow, yellow, pink, pink, another group. So for 50 pots of flowers, well done. That must be 50 divided by 5 in a group. So altogether, there are 10 groups. Since you're asking for the last one, which is pink, well done. What about 33rd? With the same method, we find out this 33rd divided by 5, you got 6 remainder 3. Oh. 6 means what? Not really. 6 means 6 group. That means we have 6 groups of red, yellow, yellow, pink, pink, red, yellow, yellow, pink, pink, red, yellow, yellow, pink, pink. 8, but you still got 3 remains. Who are those 3 remains? That is not yet a completed group. Then you can count red, yellow, yellow. So the number 33rd must be yellow. This is a very, very basic periodic question. That is like you first find out the group first. What is the pattern group? How many such things in a pattern group? For example, for this one, red, yellow, yellow, pink, pink. Those are in one group, right? Red, yellow, yellow, pink, pink. Those are in one group, right? So that's what we have as how many such things in one group. Then you find out how many groups by using division. If there is remainder, then you see remainder what? Like remainder 1, then you count. Like remainder 2, then you count. Right? Then let's continue to go further. Like this one. I'm going to pair it up. It goes, pair the upper and lower letters in the table below to form groups. For example, the first group is AX. The second group is BY. So what are the letters in the 20th group? I will give you 30 seconds to try by yourself. Let's try 38 groups. This is also basic. Try. So far I didn't get any correct answer. Oh no. Okay, time's up. Guys, let's find out. Miu just said that we need to find out about the groups, right? So how many pairs are there should be in one group? Can I say, Miu, you see what A, B, C, so 3 in a group. Not really. You take a look. The next A is with AY. This one is AX. Are they the same? No. So seriously, it's supposed to be 6 in a group. 6 in a group. Because ABC, yes, ABC, yes, but below is XY, XY, XY. So you will see the next first AX here. That is 6 in a group, 6 in a group, 6 in a group. If so, then you can use 20 divided by 6 in a group, 6 in a group, 6 in a group to find out it's supposed to be 3 groups, but remainder 2. 3 refers to 3 groups, and those remainder 2 you need to count. Remainder 1, that is the first one from the group, which is AX. And the second one is BY. That's why you can go to the answer BY. This is method number 1. That is you pair up to find out. Actually, you can also do it in the other way. What if we can just separate them? Like for the first row, right? For the first row, there's ABC, 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 3 in a group, 3 in a group, 3 in a group. So we can directly use 20 divided by 3 to find out that is 6 remainder 2. 6 group, and for the remainder 2 is A and B, which means B. And for the second row, which is XY, 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 X, Y. 2 in a group, 2 in a group, 2 in a group. So you are using 20 divided by 2, that you got completely 10 groups. Completely 10 groups without any remainder. So the last one must be Y. You combine them in the end, that's BY. Same answer. Not AX, no. Both method will lead you to BY. This is about pair up. Not always need to pair up. All right, you can also do it separately. Especially, I remember one question in SESMO. A very complicated pattern, but you separate them, that makes easy. Right? Here we go, let's continue. What about this one? This one is more crazy, right? It says Mira writes a number sequence as shown below, like 5, 4, 4, 2, 3. 5, 4, 4, 2, 3. 5, 4, 4, 2, 3. Continue, make a guess. What next? 5, 4, 4, 2, 3. Now the question is asking, how many times does number 4 appears in the first 234 numbers? Ooh. You might say, Mu, I think this is rather like page problem. Not really, guys. Again, you will see they are in groups, right? Let me just show you about the groups. Now, how many numbers should be in one pattern group? You see? 5, 4, 4, 2, 3, one pattern group. That is 5, 4, 4, 2, 3, another pattern group. And continue with 5, 4, 4, 2, 3, another pattern group. So actually 5 in a pattern group, 5 in a pattern group, 5 in a pattern group. So in these 234 numbers, 5 in a group, 5 in a group, 5 in a group, you will find out there will be 46 group, but you still got 4 remain. Guys, who are those remainder 4? That is 5, 4, and 4, and 2, right? Okay, is that the end? So the answer is 46. 46 times. Very tricky. This one very tricky. Is it 46? Well done. Not really, because 46 refers to 46 groups. Each group got how many 4s? 1, 2. 1, 2. 1, 2. So each group you got 2 of those. So you need to use 46 times 2 to go to 92. Is that the end? Why not? Why not? How about those remainder 4? You still got 2 more 4. So that's why you still need to add back that 2 more 4 to go to 94 4s. This is very tricky. But then again, for periodic problem, always to find out the pattern group first. This is something very, very important. Always find out the pattern groups, and then to find out how many pattern groups using division. If there is remainders, you need to pay attention to it. Remainder 1, that means the first one in the pattern group. Remainder 2, that means the second one in the pattern group. If there isn't any remainder, that means everybody in a completed group. That means the last one of the group. All right, so easy, right? But this one is about kicking out. Now we have so many animals arranged there. Now I need you to find out the patterns and find out number 26. Who is it? I will give you 30 seconds to think about that. Who is that number 26 animal? So far I get nothing. Really? Seriously, the cat? I don't think so. Hey guys, did you notice something? Where is the pattern group? Good. Actually, you will find out that though you got altogether 26 animals, for the first 6, Are they really, really in the pattern group? No. The difference for the remaining 20 of those the, the animals. That's why you need to kick those which is not in the pattern group out, which is 26 minus those 6. You are not in the pattern group. Those 20s are in the pattern group. So you would find out for the pattern group, 5 in a group, 5 in a group, all the way to number 26, right? Which is actually the number 20 in the pattern group. So you need to use 20 divided by 5 in a group, 5 in a group, 5 in a group to find out there are 4 groups. No remainders. So that means the last one must be the last one, which is the mouse. All right. So when you find out that apart from the pattern group, you got something they're not really the patterns. They're not within the patterns. Kick them out first. All right. But this is not the most difficult part in periodic problem. The most difficult part is when we combine it with calendar problem. Basically, calendar problem is also a kind of periodic problem. Like say we need to find out. Since actually for calendar, we also got patterns. We also got pattern groups, which is about weeks. Every week it must start with Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, 7 days a week, 7 days a week, and 7 days a week, right? So now the question that this year, March the 19th falls on a Wednesday. So what day will there be in 30 days? In 30 days, actually, that means after 30 days, right? This is about English. In 30 days, that means after 30 days. I'm going to count it one by one. Good job. So fast. No way. We are not counting it one by one. We use the divisions to find out. After 1 day, it will be Thursday. After 2 days, it will be Friday, right? So after 30 days, let's try. Since 7 days in a week, 7 days a week, 7 days a week. After 7 days, you will go all the back to Wednesday, right? So you divide it by 7 to find out there are 4 groups, but remain the 2. That means after 30 days, that is already 4 weeks later, but you still got 2 days remain. That means after 4 weeks, not enough. You still need to go 1 more day after, which is after Wednesday, Thursday. Then remainder to Friday. That's how you can go to the answer, Friday. Very easy, right? So then again, for the just now what we mentioned about working backwards. Working backwards, always draw train diagram. And for periodic problem, always use division and pay attention to the remainder. That's what I have today. Thank you so much. And then I will need you to remember that this is the second lesson that we have for the Advanced Modular Bootcamp. And next Tuesday, which would be on calculation conducted by teacher Apple, also we will start at 7 p.m. all the way to 7:40. It's on calculation on arithmetic sequence. Very crazy one, huh? And then the comparison and replacement. All right. So for this part, don't forget. And I will need to remind you that also today is the last lesson of our GEP 200 essential questions. So thank you so much for today. And if you got any of the question, please feel free to ask in the group. And also after today's lesson, later on, I will just publish the daily challenge and the bonus in the group. Don't forget to do so and you can earn extra coins. See you guys next Friday.